Good evening. Myself Kavipriya, Assistant Professor, EC Department, SNS College of Technology. Today I am going to deliver a topic LVDT. LVDT is a linear variable differential transformer. It is a type of inductive transducer which converts linear motion into electrical signal. So this is a constructional picture of LVDT. So LVDT transformer, which is nothing but linear variable differential transformer, consists of single primary winding and two secondary winding. Supply is given to the primary winding and output is measured from the secondary winding. So we have two secondary windings. So the output voltage, the voltmeter is connected between the secondary windings. So we have a primary winding P and two secondary windings which is denoted as S1 and S2. So number of turns of secondary windings are equal. We place them on both sides of the primary winding. Supply is given to the primary winding and output is measured from the secondary windings S1 and S2. In between S1 and S2 and voltmeter is get connected. And we have a iron core which is placed inside the former. So we are going to measure the displacement of the iron core and the displacement is get converted to the voltage here. And next is a working principle of LVDT. Here we are going to consider three cases. Before that, the output at the secondary winding S1 is denoted as E1 and output at the secondary winding S2 is denoted as E2. So E1 and E2 is nothing but it is a EMF, generated EMF due to the flux linkage in the secondary windings. So the differential output E out is given as E1 minus E2, which is nothing but it is a difference in of EMF generated at the secondary winding S1 and the secondary winding S2. First case, the core is placed at the null position, which means that there is no displacement of the core. So the flux linkage at secondary winding S1 will be equal to the flux linkage at the secondary winding S2. So the generated EMF E1 will be equal to generated EMF E2. So E out is E1 minus E2. So E1 and E2 are equal here. So E out is equal to 0. Second category, here we will be moving a iron core to the upward position. So for upward position, the flux linkage with the secondary winding S1 will be more when compared to the flux linkage with the secondary winding S2. So the EMF E1 will be more when compared to E2. Since E out is E1 minus E2, E1 is more here, so E out will be positive. Category 3, the core will be moved to the downward position. So the flux linkage at the winding S2 will be more when compared to the flux linkage with the winding S1. So E2 will be more when compared to E1. So E out is E1 minus E2. So E2 is more. So E out is negative. So this positive or negative is based on the displacement of the iron core. So the displacement is get converted to voltage here. And next is the advantages of LVDT. The measurement here is of high range. It can be from 1.25 millimeter to 250 millimeter. And since the iron core is moved inside the former, there is no frictional losses. And the input here is very high, so there is no need for any amplification. And it is very sensitive. And the losses here, hysteresis losses here is very low. And the power consumption is only about 1 watt, which is very low when compared to other transducer. And here the displacement is directly converted to electrical signal. And next is a drawback. LVDT is sensitive to stray magnetic field. So we require some setup to protect LVDT from stray magnetic field. And also LVDT easily affected by vibrations and temperature. And next is the applications of LVDT. So LVDT is used to measure fluid levels, it is used to inspect assembly lines, and it is used in power turbines. So LVDT act as a secondary transducer. So bore-bond tube act as a primary transducer which converts a pressure into linear displacement. Later LVDT converts a displacement into electrical signals which after calibration gives a reading of the pressure of the fluid. And that's all about construction, working principle, drawback and advantages and applications of LVDT. Thank you.